This is chapter 7.1, and it is problem number 39, very similar to problem number 35 and 37, exponential growth kind of a problem. So I'm starting out with the population of Austin being 494,290, and during the next 10 years, it's going to increase in size by 3% a year. And we need a model giving the population 10 years after 1990. So if you remember, our exponential growth model is y is equal to a times 1 plus r to the t. Well, we're solving for y, but our a is equal to 494,290 times 1 plus our r is 0.03, 3%, and our t is 10. So let's just go kind of right over here to the calculator and plug those numbers in. So I have 494,290 times 1 plus 0.03. I could have just written 1.03. That would have been just fine. To the 10th power. I press enter, and my answer is 664. Let's get a pen again. 664,284, which is also the answer in the book. Then part B says, graph the model and state the domain and the range. Okay, well, we're going to graph it then. So I'm going to go to my y equals. I'll clear these formulas out there. So I'm just going to enter in my formula, 494,290 times 1.03, close parentheses, caret x, because I want to have it as a model, and x will be the number, it will stand for the number of years. So if I'm going to graph that, I'm going to have to change my window because I can see that I'm going to have a pretty large number. So I'm going to go to my window right at the beginning here. I only am really concerned with 10 years, so I'm going to start at x at 0, and I'm going to go my x maximum at 10 years, and I can leave my scale at 1. And my y minimum, well, you know, I'll make my y minimum 0, but I'm going to make my y maximum 700,000. 700,000. And I'll make my y scale by hundreds of thousands. And now let's see what it looks like if I push graph. Well, there it is. So I can see it going up. It starts pretty high because it's starting over here at our almost 500,000, and it's going up to like 700,000. I could have started my y-axis a little bit lower, but this kind of gives you a sense of where we're starting and how it's increasing. So I've graphed the model. Now my domain on this model, because they're telling me in the problem I'm only concerned about the 10 years from 1990 to 2000. So my domain, let's get here, get to the domain. Let's give us a pen. My domain, which is my x values, is really, I can either call it from 1990 to 2000, but really what I'm going to do is I'm going to say my domain is 0, x, 10. Or if I was writing it in interval notation, I would say my domain is bracket 0, comma 10. Those are really those are the years that I'm concerned about. And estimate, and the range, well, the range for this particular graph, my range is starting at 494,290, and it's ending at 664,284. So my range, always start with the lowest one, 494,290, comma, 664,284. Bracket. That is my range. Now, in the book, it does say that for domain, well, they say the domain can be, what do they say in the book here? It's the answer. They say that the domain is t greater than or equal to 0, but they don't stop it at 10. And the same thing for the range. They just say that the range is greater than or equal to 494, 290. But that could really go either way, because I think the problem is actually limiting us to the 10-year period. But I guess the key one is that the lower value, and making sure that everything else is greater than the lower values. But to cap it off, it would also be acceptable. Now I'm supposed to estimate when the year when the population was about 590,000. Well, the easiest way to do that is to go back to our graph, our y equals. And we have our formula for the equation of our line, but let's go make another line at y2, and we'll say y2 is equal to 590,000. So 590,000. That's when that population is 590, and I'm going to graph it again. And now I have a line that's going straight across at 590. So what I'm interested in is, where does our line of 590 intersect the graph of our equation? So I'm going to go second, calc. I'm going to push number 5 for intersect. It's going to ask me which curve do I want, but since I only have two curves, the first curve is whichever one they want, and the second curve is whichever one they want. And I don't need to guess. So my intersection there, as you can see, is 5.988. So my answer to that, to part C, so C is approximately 6 years.